My name is Breanne Crockett, and I'm an undergraduate researcher in computer science at the University of Toledo. Today I'm going to tell you about my research in measuring students' engagement with digital interactive textbooks by analyzing Clickstream data. The goal of this research is to learn about how students use digital interactive textbooks to inform future textbook design and ultimately improve student success. First, let's look at what a digital interactive textbook is and how it generates the Clickstream data I examine in this project. This is an animation activity taken from a chemical engineering zybook. Zybooks is a web-based platform for digital textbooks that include static content, like a traditional book, with animations like this mixed throughout the text. My work focuses on students' interactions with the animation activities. To begin an animation, the student would click on the Start button. After each step finishes playing, the student would click Play to start the next. Each step can be paused to resume. A step can be rewatched by clicking on the previous step number. Each click is logged with a timestamp and its corresponding action. This creates the click stream that allows us to learn about the patterns in students' interactions. In my analysis of the clickstream data, I used k-means clustering to group students by the length of time they spent watching animations. I clustered on view time data for each animation, for average per chapter, and for average per animation category. In all cases, I found that students fell into one of three groups. About 20% of students were in Group 1. They consistently spent a smaller amount of time watching animations. Presumably, these are students just clicking through the animation for participation credit. Group 2 includes about 60% of students. They seem to watch animations earnestly, spending closer to average amounts of time. Lastly, about 20% of students fall into Group 3. They have consistently longer view times, indicating they spend more time digesting information or potentially rewatching a few steps. The results of clustering are interesting on their own, but also provide foundations for future work. These results can inform a generative model to predict view times for animations that students have not watched yet. Additionally, we intend to combine the clickstream data with wearable sensor data, such as heart rate variability or electrodermal activity. This combination could create a more holistic picture of students' mental workload engagement. From that, it may be possible to find a correlation between mental workload and student performance, and then determine the mental demand for an ideal animation that maximizes student success.